Question 6. Here's a sequence of patterns made from dots. We have pattern number 1, 2, and 3. And we're being asked to draw pattern number 4, following the same pattern as those. So what we have here is that the number that the pattern represents, one more than it, is the number of dots along the bottom row. So we have 2 along the bottom, then 3, then 4. So our new one is going to be 5. And we have the same thing going up the sides. So we have 5 up the sides in total, 5 along the top in total, and then 5 down the left-hand side in total, like so. Part B, complete the table. We have the pattern number and the number of dots that are in it. Pattern number 4 is this one here. We have 5 along the top, 5 along the bottom, and then 3 on each side, giving us a grand total of 16 dots. We could also have just followed the pattern that exists here. These are going up in 4s, and so it will continue to do so. So rather than draw the 5th pattern number, I know that we're going to have 20 like so. Part C, work out the number of dots in pattern 13. Well, you could keep going all the way up to 13 and then keep adding 4s. There is another way that you can do this, and that's actually by answering part D first, where you figure out the formula that is connected to the pattern number and the number of dots. So in order to get this formula, we first of all see what our pattern of numbers is going up in. So these are going up in 4s, meaning that what we have is like the 4 times table. So we have a 4n. Then what we do is, you've got 2 options here. We look at the 4 times table, doing 4 times 1, 4 times 2, 4 times 3, and see if it's any different from our pattern, which in this case, it's not. So what we actually have is the 4 times table. The other way you could figure out if we have a plus or minus at the end here is to go back 1. So back 1 to what's known as the 0th term. If we did that, we would end up with 0. So that kind of confirms that there's nothing there, because if we add 0, it doesn't do anything. So anyway, 4n, that is us answered part D. Our formula, technically un, we could write it as, is 4n. That's actually just that is needed for the expression at this level. But anyway, we can now use that formula for pattern number 13. So when n is 13, that's going to give us 4 times 13, which will be 52. That's going to be the number of dots there. But like I said, you could just count all the way up there and keep going up 4s if you wanted. What I've shown there is a more formal one, and would be definitely what you would do if they said pattern number 100 or pattern number 72. You would want to use the formula for that. Next part, there are fewer than 90 dots in pattern number k. What is the largest value of k? So the bigger and bigger this gets, eventually the number of dots will get bigger than 90. Well, what we can use, and it actually comes into what I actually wrote here on the left hand side, is this I could refer to as the number of dots, and the n refers to the pattern number. Basically, if you've got 4 times as many dots as you have patterns, then you've got 4 times as less patterns compared to dots, or in other words, we divide by 4. So this 90, if we divide it by 4, is going to give us 22.5. So we can't technically have 90. 90 won't be one of the possible dots. What will be, though, is 92 and 88, or in other words, if we look at just less than that, the 22nd pattern number, then that would give us 88 dots. That's the largest possible pattern number we can get that is fewer than 90, because notice doesn't, because this is a decimal, it can't equal 90. So 88 is actually the highest. So k equals 22 is the biggest we can get. Done.